Hello everyone. Today we are going to discuss these important and advanced theorems for circles. These theorems are relevant to your exam. For example, in GMAT, Official Guide to GMAT Quantitative Review Edition 2022, this is question number 293 and you can find it in other editions of the Quantitative Review with DS 17588. So don't think that this theorem is out of the scope and you don't have to actually understand this theorem. This theorem is well within the scope of your exam. These theorems are also covered as part of my complete guide to geometry circles, which has over 30 plus theorems which are relevant to your exams. If you haven't reviewed that video, the link is above and also in the description of the video. The important things about these theorems are that they are fairly advanced theorems. You would likely get the application of these theorems in fairly advanced questions in your exam, and if you do not know the theorems or do not know the application of these theorems, you would either end up spending too much time to derive the relationships, or most likely you would end up getting stuck and making an incorrect guess or choice, along with wasting a lot of time trying to solve this question. However, here is the positive thing about this. If you understand how to apply this theorem, how to derive these theorems does not matter. Application of these theorems is fairly straightforward as long as you know what to look for and how to apply. The numbering on these theorems may look a little bit weird because these are part of my comprehensive guide to geometry circles, and the theorem numbers are part of the 30 plus theorems we have discussed in that video. So don't get distracted with the numbering. What is important is the three different forms of power of point theorems and how to apply them. So the first form is a two chord form, and chords are nothing but secants, so it is also called a two secant form or intersecting chords form. And what it says is, if you have two chords A, B and C, D which intersect internally at a point P. Now remember, not all chords intersect inside a circle, so these two chords happen to intersect inside the circle. The theorem says that if you take the measurements from the point of intersection, such as PA multiplied by PB will equal PC multiplied by PD, doesn't matter where the chord intersect inside the circle. The important thing to note here is that we are taking the measures from the point of intersection, not anywhere else, not AP multiplied by AB and things like that. The measurement always starts from the point of intersection, and that is an important for you to remember. And just to make sure that you do not forget, I have written it down here. As I said, two chords may not always intersect inside the circle, so sometimes they intersect outside of the circles, which brings us to two secant form B, because the chords are actually intersecting outside of the circle. And again, the same relationship applies as long as you take the measurements from the point of intersection, which is PA multiplied by PB equals PD multiplied by PC. So the relationship from the point of intersection hasn't really changed. The important factor again here is that you have to measure from the point of intersection P, not any other segments. And finally, you can have a secant which intersects the circle and makes this chord AB, and a tangent which is tangent at the point T, and you have very similar relationship. But since there is only one point T, you are actually going to square this. So you have PA multiplied by PB equals PT multiplied by PT, which is PT squared. So fairly straightforward application once you understand that there exists a relationship from the intersection points of either two chords, two secants, or a secant and a tangent, and that relationship is always measured from the point of intersection. Once you understand that, applying these theorems is not difficult. I hope you found this short video helpful. Please do not forget to press like and subscribe to my channel, because there is more where it came from. If you haven't already reviewed the 30 plus theorems that are in your syllabus, please view that video. The link to the video is in the description. And if you have questions, I personally respond to all the questions on my videos, so please feel free to ask as many questions as you would like. Thank you so much for your time. All the best with your prep.